Hello everyone, welcome to Mathworld. This video is to discuss Cambridge International AS and A-Level Mathematics Paper 1, which is the Pure Mathematics 1 for May-June 2024, and the code is 9709/11. So let's move on to question number 1. Okay, so for question number 1a, express 3y squared minus 12y minus 15 in the form of 3 times square of y plus a plus b, where a and b are constants. So obviously this is solved using completing the square method. So according to completing the square method, we have to make sure the coefficient for y squared is positive 1. Therefore, we need to factorize 3. So once you factorize 3 from 3y squared, you'll be getting 3 bracket y squared minus, then the 12y becomes minus 4y, and leave negative 15 outside. And then from here, we will be rewriting the first two terms and write plus bracket squared minus bracket squared, followed by minus 15. So the term inside the bracket, it should be half of the coefficient of y. That means that will be minus 4 over 2. Okay, that will be the half of the coefficient. Then now here, I will just rewrite the 3. So from the first 3 terms, you will just combine first and third term. Okay, the terms with the square. So now I will be getting y. Now minus 4 over 2 is basically minus 2. Then you square it, and now minus 4 over 2 is minus 2, so you square it, becomes positive 4. Then minus 15. And now the next step is just to bring in the 3. So just bring it in, and you will be getting the answer. So here I will be getting 3 bracket y minus 2 squared. So 3 times minus 4 is minus 12, then followed by minus 15. At last, you will be getting 3 times y minus 2 squared minus 27. So that's all for the solution of 1a. B. Hence, find the exact solution. Hence means use the answer from previous part. Exact solutions means that your solution is not in the, your solutions are not in the decimal form. Okay, so that's the meaning of solution, exact solutions. So here, the equation now becomes 3x degree 4 minus 12x squared minus 15 equals to 0. Now I will compare with the previous question because you are given the hence here. Hence means use a previous answer. So I will copy this result. So 3y squared minus 12y minus 15 is basically 3 of y minus 2 squared minus 27. So from here, if I compare, okay, so obviously the y equals to x squared. Therefore, I will just write let y equals to x squared. That means the first equation. So from first equation, it will be 3 of y minus 2 squared minus 27 equals to 0. Okay, then now it is not y. Okay, now I change my y into x squared. Therefore, you have to change to x squared as well. Then from here, to get the x, because now you are solving first equation, which is in terms of x, so the negative 27 will be moved to the other side. Then you will be getting this expression. And now divide the whole equation by 3. That is going to be square of x squared minus 2 equals to 9. And now to eliminate the squared here, this squared, I move it to the other side. It becomes plus minus square root because it is an even degree. Okay, then now I will split. So x squared minus 2 plus minus square root 9 is basically positive 3 or minus 3. Then now here, to solve the first equation, the minus 2 move to right side becomes plus 2. So end up with x squared equals to 5. Then again, to move the square to the other side, it will be plus minus square root. Okay, now for the right side, okay, or the other expression, the minus 2 will be moved to right side. So it becomes plus 2. So minus 3 plus 2, that is minus 1. We know that x squared cannot be negative. So this is no solution. Okay, hence your x solutions will be just plus minus square root 5. Okay, question number 2. The diagram shows two curves. One curve with equation y equals to sine x, and the other curve has y equals to fx. Now A, in order to transform the y equals to sine x to the curve y equals to fx, the curve y equals to sine x is first reflected in the x-axis. Now describe fully a sequence of two further transformations which are needed. So it means that now I need to reflect my graph, my sine graph, in the x-axis first. So obviously this is the sine graph, because sine 0 is 0, sine pi is 0, sine 2 pi is 0. Okay, sine 3 pi is 0. So this upper graph is a sine graph, and it's mentioned in the question, first transformation is reflection in the x-axis. So when I reflect, right, so that means this point becomes here. 1 becomes minus 1. So all the points on the x-axis remain, and then this minus 1, okay, this minus 1 becomes positive 1. This positive 1 becomes minus 1, and this minus 1 becomes positive 1. So I just join all the cross. Okay, so this is the first transformation. And now I need to find out another two transformations, because here are two further transformations. So first of all, I will check. From here, okay, it drops to minus 2. So from pi drops to here, that means 2 units downwards, right? That means now here, I know that it involves translation, and at the same time, if just translation, the graph, okay, so here is a reference line, which is the x-axis, right? Then here is the x-axis, okay, my new x-axis, but then the shape will be the same, okay? Supposedly, if I just involve translation, so I should be this point here, right? So I should be getting like this. But then from, obviously they are not the same, right? And from here I know that I will just consider few points. So firstly, I will write my points. Okay, so now you can check when the orange color, the curve on the points on the orange curve, that is after the reflection. This one is after reflection. Right? I want to find out what's happening. So now I will check this point. Okay, and you look at here, this one moving up, moving down 2 units, here moving down 2 units. That means for my minimum point, okay, so it should be moving up here. That means before I get this graph, because it involves two transformations here, supposedly 2 units, right? Because here 2 units, that means this one should be 2 units up. So which means my pi over 2 minus 1 now has been changed to pi over 2 minus 3. Okay, so here it should be pi over 2 minus 1. It has been changed to pi over 2 minus 3. And now check one more point. Let's say I check pi 0. Okay, so here pi 0, it has been changed to, now see here 2 units, here 2 units, that means initially, alright, initially it is still pi 0. Okay, so here becomes pi 0, no change. Now if I check another point, this point with coordinates 3 over 2 pi and 1. So here 3 over 2 pi and 1. Now my new point, that means after the first transformation. Okay, here you are getting this point right now. Okay, and remember, we need to, from here, we need to move up 2 units, okay, to get this point. That means this one you move up 2 units. So when you move up 2 units from 1, that means basically it will be over here. That is 3 because you move up 2 units. Therefore, I will be getting 3 over 2 pi and 3. Okay, so that means from now here you check x no difference, but then the y value from -1 change to -3. Okay, then here 1 change to 3. So by looking at this point, right, so the change is in the y coordinates and it is triple of the original point. So from here I will just write my transformation will be stretch transformation. Because there's no change in the y coordinates. The changes are in the, there are no changes in the x coordinate and the changes are on the y coordinates. So transformations, it will be stretch with factor 3 in the y direction. Okay, after that, look at here, I will be getting all these points. And here going up, right? So these points will remain. And now here, the second transformation is okay, from this point, move down 2 units. From this point, move down 2 units. Here also move down 2 units. So everything move down 2 units for the whole graph. Alright, that means this is my second transformation. Okay, that is the translation. So because we are moving down the graph for 2 units, therefore you will just write followed by translation. Translation of, now no difference in the x, move down 2 units for the whole graph. So this will be your transformations. Okay, so here is stretch. So done for the A. Now B, find fx in terms of sin x. So from here, because of stretch with scale factor 3, right, in the y direction, so from here, my fx, it becomes minus 3 fx. Okay, then it will be, it will be positive 3 fx because of stretch. Then now, and you move down minus 2 units, this is going to be, okay, wait, fx equals to sin x. So now look at here. Initially, I forgot the initial, the very first transformation. You see, this is your original graph. Now you have reflected, okay, here, reflected in the y, in the x-axis. So when reflected means that this becomes minus sin x, right? If let's say this is your y equals to fx, so here is already minus fx, right? So minus fx. Then the blue color, because of the scale factor 3, so the blue color is basically minus 3 fx because initial was minus fx. After that, you move down the graph. So when you move down the graph for 2 units, that it becomes minus fx minus 3fx minus 2. So I should have the minus in the beginning because that is the very first transformation given in the question. Okay, therefore here it should be minus first, right? Then 3fx, then followed by minus 2. And now the function, because you need to get in terms of sin x, so your function is actually sin x. Therefore, you are getting minus 3 sin x minus 2. This is how we get it. Okay, so for question number 3, the coefficient of x cubed in the expansion power 6 of 3 plus ax is 160. Find the value of the constant a. So now I will write 3 plus ax to the power 6 equals to summation, use the formula, a plus b degree n, that is summation ncr, a r, b power n minus r. R start from 0 until n. So which means now here I will write r start from 0 until 6 cr. This is a combination. 3 power r ax to the power 6 minus r. And now I need to split the a and x from the degree so that I can find out what is my r value when it is coefficient of x cubed. So it will be 3 power r, a power 6 minus r, x power 6 minus r. So to get x cubed, that is x power 6 minus r, that means 3 equals to 6 minus r, therefore your r is going to be 3. So which means when r equals to 3, I will be getting the term of x cubed, or I will just write coefficient of x cubed. Okay, coefficient of x cubed equals to 160, which is given in the question. That means now I will write 160. The coefficient will be all the rest of the terms, right, except the x. So that means here I will get 6c3, 3 power 3, a to the power 6 minus 3, which is 3. Then you will be getting 160 equals to 540 a cubed. Hence, your a cubed is 160 divided by 540. That is going to be 8 over 27. And now my a is cube root of this value. That is going to be 2 over 3. Okay, that's the value of a. Now b, hence means use the previous answer. Find the coefficient for x cubed. Just now given coefficient for x cubed is 160. Now for new expansion, so 3 plus ax degree 6 times 1 minus 2x. So here I will just do expansion. This is going to be multiply with 1 and multiply with negative 2x. So you will be getting 3 plus ax degree 6 minus 2x times 3 plus ax degree 6. So in order to get x degrees cube, x cube here, the coefficient for x cube, we have done it just now. That is 160. Okay, so which means now here I just need to simplify the second expression. So again here I split 6r, then 3r ax degree 6 minus r. So your r start from 0 until 6. Now remember, just now, when only 3 plus ax degree 6, my r is 3. Okay, which is here. So which means the first one, it will be r equals to 3, which is 160. And for the second expression, this is actually same as just now. It's just that now here you have x degree 1. Therefore, this must be r equals to 2. Okay, so now here I will just write 6 minus r equals to 2. Not r equals to 2, sorry. The x must be degree 2. I will write x must be degree 2. Because you have x degree 1 outside. So therefore 6 minus r equals to 2. Hence my r is going to be 4. Then I will just get the coefficient of x cubed. First term, you get it from the previous question, 160. Second term, alright, now the coefficient will be 2 minus 2. And together with all of this, together with the a as well. Okay, then now here you will be getting 2 times 64, and then 3 power 4, a to the power 6 minus r will be 2 here. Okay, therefore here it will be 160 minus 2430 times 2 over 3 cube. 2 over 3 squared. Why 2 over 3? Because your a is 2 over 3. Then here I will just write my a equals to 2 over 3 from part A. Okay, then here you will be getting the answer of minus 920. So that is the solution for part B. Okay, now for question number 4. The equation of a curve is y equals to fx, where fx is given by this expression. The following points lie on the curve. Non-exact values have been given equal to 5 decimal places. So find the value of k. Give your answer equal to 5 decimal places. Your k is the y coordinate of the points B. Therefore, I will just substitute the x value into my curve equation. Okay. So from here, B 2.0001 and k, that means x is 2.000001 and then my fx or my y equals to k value. So now just replace. So k equals to 2 times 2.0001 minus 1, that is the first bracket, then square root of 3 times 2.0001 close bracket minus 2 and another minus 2 outside. Okay, then from here you will be getting 3.0002 times square root 4.0003, then minus 2. So your k is going to be 4.0063. That is 5 decimal places. So that's the k value. Now part B, the table shows the gradients of the chords AB, AC, AD, and AF. Now, gradient of the chord. Now B, find the gradient of AE. Okay, here. Give your answer equal to 4 decimal places. So now, I will just find the gradient using the points A and E. So go back to original question. Your A is 2, 4. Your E with these coordinates. So I will copy down these two coordinates first. So which means my A with 2, 4. My E, the coordinates will be 2.1, 4.63, 566. Okay, when you refer to the coordinates here. So now gradient. So MAE. So for your information, if let's say you are given 2 points, x1, y1, x2, y2. So the gradient M equals to y2 minus y1 over x2 minus x1. Therefore here, I will be getting 4.63566 minus 4 over 2.1 minus 2. Then you will be getting 6.3566 because of 4 decimal places. So it means that now here should be 6.3566. Okay, now C. Deduce the value of f prime 2 using the values in the table. So for information, f prime x means gradient of the curve. Or you can say gradient of tangent. So f prime 2 means gradient of the curve at x equals to 2. Okay, so now refer back to the table. So look at the x values here. Your A is, the x value for the A is 2, B is 2.001, C is 2.001, D is 2.01, E is 2.1. So it is close. Okay, it will be from B, right? From 2, then you consider up to 2.1. What's happened to the, what is happening to the y value? Okay, so now we need to calculate, we need to deduce the gradient. So we know that gradient is basically the y value over the x value. So from here, I will say that my f prime 2 is basically, okay, you look at the coordinates here. right after the E, the point F, the x coordinate becomes 3. That means we should not consider the point F in our gradient. So now you refer to the table. It means that you just consider the chord and the gradients up to AE. Okay, so from here, now from here, when you refer to the AE, okay, the E, where is the E? The E here is 2.1, and now we need to find out F prime 2. So we need to choose a value which is close to 2. Okay, so which means I will consider probably first 3 because these 3 are close to 2. Alright, so when you refer to first 3, 1, 2, 3, okay, so even this 6.26, the 2AD, so when you consider AD, A to D, this is 2.01. So when you compare to B and C over here, right? So here B and C, the x coordinates will be much closer to 2. But if you take 2.01, that is 0.01 away from the 2 already. So we will rather take B and C to deduce the F prime 2. That means now here, when you refer to B and C, right, don't use a D because it is 0.01 units away from 2. So I will check these two values. Okay, and then now when you consider these two values, the gradients will be from 6.2501 to 6.2511. So I will just take these two values for the consideration. Right, so which means correct to 3 significant figures, that will be 6.25. Okay, because these two values are closer to x equals to 2 compared to points D, points E, and point F. So here, therefore, I will just write it will be 6.25. So this is how we deduce the gradient. Okay, now question number 5a, prove the identity. So to prove the identity, we always start from the side which is complicated. That means left side, right? In this case, so sin square x minus cos x minus 1 over 1 plus cos x. Now, here we need to prove that it only has cos x. So now here I have sin square x. That means refer to the identity. Sin square x plus cos square x equals to 1. Eliminate the sin square x and change to cos. That means now sin square x equals to 1 minus cos square x. Right, so I will change my sin square x into 1 minus cos square x, then minus cos x and minus 1 at the back, just rewrite, over 1 plus cos x. Now basically when you refer to this form, the first and last term will be cancelled off. Okay, because plus 1 and minus 1, so you cancel that, and then now you will just get minus cos square x minus cos x. So now minus cos square x minus cos x over 1 plus cos x. So obviously the common term is minus cos x in the numerator. Once you have factorized minus cos x from the numerator, you will be getting cos x plus 1, then over 1 plus cos x. So now the 1 plus cos x and cos x plus 1, actually they are the same term. Therefore here, after you've cancelled off both the numerator and denominators, that means you will be getting minus cos x. So this is what we need to prove. B, hence means use a previous answer. Okay, now you check. The sin square x minus cos x minus 1 is the numerator, same. But then the denominator is 1 plus cos x, but now has been changed to 2 plus 2 cos x, which means now here I have to factorize my positive 2. Then I will be getting 1 plus cos x. That equals to 1 over 4. And now here I know that to get this form, it will be same as minus cos x. So which means now the 2 will be moved up first. Okay, so I will rewrite So it becomes 2 over 4 on the right side, and the left hand side I will just replace by minus cos x, because we have proven the identity in the previous part. So which means now your cos x is negative half. And look at the interval. It is valid for all 4 quadrants. So which means I will draw the quadrant diagram. Okay, cos is negative means that it will be in the second and third quadrant. Okay, cos negative. So now I will get the basic angle. Basic angle, that is at cos half. So at cos half you will be getting 120 degrees. Sorry, at cos half is basically 60 degrees. Okay, which means here I will label 60 degrees and this is 60 degrees. These two are my basic angles. And then now look at the interval. Your x is defined from 0 to 360 degrees, which means I have to accept this as the first angle, and my second angle is the green color. Okay, so which means now my x, it will be 180 minus 60 degrees, and then 180 plus 60 degrees because of the third quadrant. So the second quadrant will give you 120 degrees. Third quadrant, it will be 240 degrees. So that's all for this solution. Okay, question number 6. The function f is defined by fx equals to 2 over x squared plus 4, where the x is less than 0. That's why it is on the left side of the graph. The diagram shows the graph of y equals to fx. Now A, on this diagram, sketch y equals to f inverse. Show any relevant mirror line. Okay, so now to sketch y equals to f inverse, we need to sketch y equals to y equals to x first. That is our mirror line. So which means y equals to x. This is y equals to x, right? Whereby this is 45 degrees. Here is 45 degrees. Okay, so now when you look at the inverse, the original function here, this is y equals to fx. I know that my domain for fx, okay, domain for f, I will just write domain for f is x values, means that x less than 0. Now, domain of f equals to range f inverse, which means my range f inverse means my inverse graph will be less than 0. I will just copy the answer here and put it here. Domain is referring to x. Range is referring to the fx, or sorry, f inverse or y value. So now I know that my inverse graph later on will be all negative. Okay, and then from here you can just do the reflection. Actually, it is a reflection. So that means now this y value, okay, you can check this y value, the range of f. Let's say this is a, okay, going up at least a. So means that fx at least a. So now my domain f inverse, it will be same as range f, which means my domain f inverse is x greater equals to a. So now your a is positive y. Okay, that means here is positive a. So which means now my x value will be at least a. So it looks like, okay, it can be a onwards here, something like this, because here is straight line. So here you draw a straight line. Okay, but then when look at the range f inverse, the fx is always negative. So that means it's like this. Okay, so you can just check. It will be the reflection. 90 degrees. So you just draw up to this line. Okay, so that is your inverse graph. So you can check here, this point. Okay, so I think my A is too far away. It should be the reflection. So you can just measure probably here. Alright, so this is the reflection. So I will label this as y equals to f inverse. Alright, so now find an expression for f inverse. So now to get the f inverse, let y equals to fx. So which means y equals to 2 over x squared plus 4, and now get the x as a subject, which means 2 over x squared equals to y minus 4. Now the x squared move up and the y minus 4 move down. Okay, so I will be getting 2 over y minus 4 equals to x squared. And now I need to get the x. So my x, when I move the 2 to the other side, is supposed to be plus minus. But then for the f inverse later on, I need to decide whether it is positive or negative. So change the x into f inverse. Okay, write the square root first. The y will be replaced by x. Then now you have to decide whether I choose plus or minus. Look at your inverse graph or look at this constraint. Your f inverse is always less than 0. Therefore, I have to put negative. Okay, what's the reason? Because domain f, x is less than 0. Therefore, range f inverse equals to domain f. So this will help me to decide whether my f inverse is positive or negative. Okay, done for the inverse function. Now solve the equation fx equals to 4.5. So your fx, just copy this, 2 over x squared plus 4 equals to 4.5. So the 4 move to the other side, it becomes 0.5. So I'll get 2 over x squared equals to 0.5. Therefore, the 0.5 move down. You just swap the position with the x squared. Okay, so here I will get x squared equals to 2 over 0.5. That is going to be 4. Which means now my x will be plus minus square root 4. It will be plus minus 2. Now, when you look at the graph, your graph is defined for x less than 0. That means now here, okay, given x less than 0. Therefore, your x is only negative 2. That's the solution for C. Now D, explain why the f inverse equals to fx has no solution. So f inverse equals to fx means intersection points. Okay, means intersection between two graphs, between y equals to fx and y equals to f inverse. So now since we have sketched the f inverse on the same diagram here, alright, obviously there's no intersection. Okay, so that means here now you just write f inverse equals to fx has no solution because both curves do not intersect. Okay, now next question, number 7. In the diagram, AOD and BC are two parallel straight lines. Okay, now arc AB is part of circle with center O. AB. Okay, here, center O. and radius 15. That means here is also 15. Now angle BOA is theta radians. Arc CD. Here is the arc CD. It's a part of circle with center O and radius 10. That means here is 10. Now angle COD is half pi. Here is half pi. Okay, now A show that theta is 0.7297 equal to 4 decimal places. So to show the theta, now I need to use, okay, look at this right angle triangle, because here is 90, here is also 90. So now if here is pi, that means this angle, right? You can find out what is this angle for COB, because we know that this is the opposite side. Here is hypotenuse and this is adjacent. Alright, so you are given adjacent and hypotenuse. Therefore, I can just use a cos to find the COB before I get the theta. So now cos angle COB equals to adjacent over hypotenuse, means 10 over 15. That is OC over OB. OC over OB. This is 10 over 15, which is 2 over 3. Okay, that means now here I will say my theta is basically pi over 2, because here is pi over 2. Right, pi over 2 minus inverse cos minus angle COB. So that means here angle COB is basically inverse cos or arc cos 2 over 3. So here I will write pi over 2 minus arc cos 2 over 3. And this is radians because does not have degrees. So here it will be 0.7297. So shown. Done for the A. Okay, now B, find the perimeter and area of the shape ABCD. Give your answers correct to 3 significant figures. So for the perimeter of ABCD, which means I just need to find here. All these will be the perimeters. Okay, so now I know that here is 15. This BC, I need to find out what is my BC first. And then here is 10. I need to find out these two arc lengths. So first of all, I find the BC. So to get the BC, I will use the right angle triangle. So now when you look at here, okay, the BC, this is opposite. Just now we have found this angle. Or probably I don't use the angle, I will just use Pythagoras theorem. So I draw BCO triangle first. This is O. Here is C, this is B. So your OC is 10, OB is 15. So here 10, this is 15. That means now my BC, according to Pythagoras theorem, that is square root of 15 square minus 10 square. Then you will be getting square root of 125, which is 5 square root 5. Okay, so now I found BC. Then I can find the AB and the CD using the arc length formula. Okay, so I will direct just find perimeter. So perimeter is basically 15, or I will say 15 plus 10, right? So 15 plus 10 plus AB. Now for your information, if let's say you need to calculate the arc length of a sector, this is theta, here is r, the arc length is theta r. Okay, so now I just need to find out 15 theta, that is my arc length. So my theta already found in the previous part. That means you will be getting 0.7297 times 15. That is my arc length. So arc length is done. Okay, then find the BC, that is 5 square root 5. And plus with the arc length of CD. So arc length of CD, the theta is pi over 2. And then the r is 10. So pi over 2 times 10. That means here you will be getting 62.8. That is the perimeter. And now area. Okay, so to get the area of sector, these two area of sector, right? Area of sector plus area of triangle. So here I will write area equals to area of sector AOB plus area of triangle BOC then you plus area of sector DOC. So area of sector, use back the same sector. The formula is area equals to half theta r squared. Alright, so now the first one is half AOB, which is theta. Theta already found 0.7297. So here I will write 0.7297. My R for the sector AOB is 15. This is a 15. Now, my area of triangle BOC can just refer back to this. Since here is 90 degrees, we have found the BC just now, 5 square root 5. That means this is going to be half base 5 square root 5 times height, which is 10. Then plus area of sector DOC, again half. The angle for this sector is 90 degrees. Okay, I will just write pi over 2, then the r is 10. So it will be pi over 2 times 10 squared. Then now here you will get the total of 216.5327, and the question says 3 significant figures. Therefore, refer to the 5, round up, because it is 5 and above. So therefore, your answer is 217. That is the area of the ABCD. Question number 8a. The first three terms of an arithmetic progression are 25, 4p minus 1, and 13 minus p, where p is a constant. Find the value of the 10th term. So, arithmetic progression, my a is basically 25. Now, I need to know what is my d. So, my d, which is a common difference, is second term minus first term. It is same as third term minus second term, which means now here, my d is, or probably before I get the d, I have to find out what is my p first. So 4p minus 1, this is my second term, minus 25 equals to 13 minus p, that is my third term, minus the second term. That's the meaning of common difference. Okay, that's the calculation of common difference. So from here, you will get 4p minus 26. Then for the right side, 13 minus p, the minus you bring it into the brackets. So it will be minus 4p, minus is a plus 1. So now I will write 4p minus 26 equals to, simplify the constants, it will be 14. Minus p minus 4p minus 5p. So now the p will group together. So I will move the minus 5p to left side and minus 26 to right side. That means now here you will be getting 4p plus 5p equals to 14 plus 26. Therefore, left side is 9p, right side is going to be 40. Hence, my p is 40 over 9. Okay, So here I will just write my second term, t2 equals to 4p minus 1. Okay, then now this is going to be 160 over 9, so 151 over 9. That means now my d, common difference, d equals to t2 minus t1. That is 151 over 9 minus the first term. First term is 25. That means here you are getting negative 74 over 9. That is my common difference. Okay, and then you are requested to find the 10th term, which is t10. So now t10 is a plus 9d, because our formula is tn equals to a plus n minus 1d for arithmetic progression. So just replace the values. Your a is 25 plus 9 times negative 74 over 9. So basically it's 25 minus 74. That is going to be minus 49. This is our 10th term. Okay, part B. The first three terms of a geometric progression are 25, 4q minus 1 and 13 minus q, where q is a positive constant. Find the sum to infinity. So for geometric progression, your first term a is 25. And again, now I need to find out what is my q. So geometric progression, we have the r, common ratio. Common ratio is basically t2 over t1 equals to t3 over t2 is a ratio. That means now I will use 4q minus 1 divided by 25 equals to 13 minus q divided by 4q minus 1. Then from here, to find out the q, okay, to solve the q, just use cross multiplication. Then you will be getting 4q minus 1 times 4q minus 1 means squared equals to 25 times 13 minus q. And now just do the quadratic expansion. So for the left hand side, I will write a minus b squared, that is a squared minus 2ab plus b squared. So you square the 4q, that is 16q squared. 4q times minus 1, then times another 2. That is minus 8q. Minus 1, you change to plus 1 squared, that is 1. So right side, just do expansion. 25 times 13, you will get 325. 25 times minus q, that is minus 25q. Okay, so now group all the terms or move all the terms to the left side in order to get the quadratic equation. So I will get 16q squared minus 8q plus 1 minus 325 plus 25q equals to 0. Then you will be getting 16q squared. Now minus 8q plus 25q, that is plus 17q. Plus 1 minus 325, that is minus 324, equals to 0. This is a quadratic equation. And now here, these three terms can be factorized into q minus 4 times 16q plus 81 equals to 0. Okay, so either q minus 4 equals to 0 or 16q plus 84 equals to 0, which means your q equals to 4 or your q equals to minus 81 over 16. So now, refer back to the question, given that the q is positive. That means now here, given q is more than 0, hence my q is just 4. And now, once you have found the q, we need to find the r, common ratio, before the sum to infinity. Because our purpose is to find the sum to infinity. So now my R common ratio, that is either you use the left side or right side for the calculation. So I will use a left hand side. That is 4q minus 1 over 25. So 4q minus 1 over 25. Okay, this is to get the R common ratio. Therefore, from here you will be getting 15 over 25. That is 3 over 5. Now, for geometric progression, your A remains 25, your R is 3 over 5, and the question is asking for sum to infinity. So now S infinity equals to A over 1 minus R. That is the formula. That means here I will get 25 divided by 1 minus 3 over 5. That is going to be 25 divided by 2 over 5. Then you just calculate this using calculator. That is 125 over 2. So that's all for this sum to infinity. Now next question, number 9. Okay, the diagram shows parts of the graph with this equation and the lines x equals to 2.4 and y equals to 1. So that means this is the curve. Y equals to 1 over 5x minus 4 to the power of 1 over 3. Okay, now the curve intersects y equals to 1 at 1, 1. So this is the intersection point. Find the exact volume of the solid generated when the shaded region is rotated through 360 degrees about the x-axis. So you are rotating this region 360 degrees. Okay, so basically our volume formula is V equals to pi. Since it is rotated about x-axis, therefore dx here. Hence here integrate y squared. Okay, so when you integrate y squared dx means that you are referring to the x-axis. Now if you integrate this graph, okay, always the region below the graph. So when you calculate this, you are counting the orange region, okay, which is here. But then you need to calculate what is the volume of the solid generated. It's not the bottom part, it's this part. Which means now what to do is, for your information, if I rotate this whole region, okay, this whole rectangle in the x-axis, actually I'm getting a cylinder. Okay, I'm getting a cylinder, and this is my R. This is my radius. And then I will be getting this cylinder. And this is my height, h. Because our volume for cylinder is pi r square h if you are given this shape. Here is the r, here is the h. So now my r becomes this height, which is 1. Okay? Because my y coordinate is 1. This is my 1. Then my h is basically 2.4 minus 1. So this is 2.4 minus 1. Okay, so then I find the volume of the cylinder. Then I minus the volume below the graph, which is counted using this formula. So that is the whole idea to solve this question. Right, that means now here I will just write volume equals to pi r square. Okay, my r is 1. So pi r square, my h is going to be 2.4 minus 1. There is the volume of the cylinder. Then I minus the region. So for the region, integrate or pi integrate y squared. So it will be 1 over 5x minus 4 to the power 1 over 3. This is my y. Then I squared it. Then dx. Since here dx, that means you need to integrate from x equals to 1 until 2.4 because the region is actually bounded the region is from 1 to 1.4 for the x values. So here it will be 1, lower limits 1, upper limits 2.4. Okay, so for the first term is pi, 1 square is 1, 2.4 minus 1 is basically 1.4. Then minus pi. Now, this 2, when you bring it in, it will be using this formula, AB degree m. Right? So, I will write, the A degree m, and then another degree n outside, which is a 2. So, this is same as A to the power of mn. So, it means that the 2 can be just combined with 1 over 3. But since the 5x minus 4 is in the denominator, I will just move up first. So it becomes from 1 to 4 integrations, the limits. So when I move up, it becomes negative degree. So the negative 1 over 3 times 2 becomes negative 2 over 3. Okay, when you apply this formula. And now just integrate. So this is going to be 1.4 pi minus pi. For the integration, integrate ax plus b degree n dx. So need to rewrite this function. The n change to n plus 1 over n plus 1, and differentiate ax plus b, that is a plus c. Okay, this is with limits. If without limits, so if with limits, then just ignore the plus c, and provided the n is not minus 1. So from here, when I replace the function in the formula, it becomes 5x minus 4. The degree negative 2 over 3, you plus 1. So negative 2 over 3 plus 1, it becomes 1 over 3. Then over 1 over 3, and differentiate 5x minus 4, that is 5. Okay, the a comes when you differentiate ax plus b. And then don't forget the limits. Then now, here, simplify. 1.4 pi now the denominator, it becomes 5 over 3. So when I move up, it becomes 3 over 5. Okay, and replace the x by 2.4. So I will get 5 times 2.4 minus 4, that is 8. Then power 1 over 3. Then minus, when the x is replaced by 1. So that is 5 minus 4, that is 1 to the power 1 over 3. Then now here, you will be getting 1.4 pi minus 3 over 5 pi. 8 to the power of 1 over 3 is basically 2. So 2 minus 1 to the power of 3, 1 to the power of 1 over 3 is still 1, because 1 to any degree is 1. So 2 minus 1 is basically 1. So which means 1.4 pi minus 3 over 5 pi. So end up with 4 over 5 pi. That is the exact volume. Okay, question number 10. The equation of a circle is given. The line with equation y equals to mx plus c passes through the point 0 minus 9, and it is a tangent to the circle. Find the two possible values of m, and for each m, find the coordinates of the point at which the tangent touches the circle. So when straight line is a tangent to the circle, that means it is just touches the circle, which means only one intersection point. Okay, so now basically, when it is a tangent, means that you need to solve these two simultaneous equations and make sure just one root. Okay, so or one intersection point. So now I will copy the curve equation. Let this be first equation, and then my second equation is a straight line. Now it's mentioned that this straight line passes through point 0 minus 9. So this line passes through 0 minus 9. That means this point is on the line y equals to mx plus c. So which means the x coordinate 0 the y is minus 9. So now my y equals to mx plus c, I will replace it. It will be minus 9 equals to m times 0 plus c, which means my c is basically minus 9. So I will rewrite my straight line equation, that is y equals to mx minus 9, because plus c is plus minus 9, that is minus 9. Now I'm solving these two simultaneous equations. Okay, so first equals to, or substitute second into first. When I solve the simultaneous equation, replace the y. Therefore, you will be getting x minus 3 squared plus my m is mx minus 9. Then square, that is my y squared, that equals to 18. And now here I need to do expansion. So when you do expansion, a minus b squared, that is a squared minus 2ab plus b squared. That means you will be getting x squared minus 6x plus 9 for the first quadratic expansion. And now square of mx minus 9, that is going to be m squared x squared, then minus 9 times mx times 2, that is minus 18 mx, then plus 9 squared is 81. And the 18 on the right side will be moved to left side. It becomes minus 18 equals to 0. So obviously this is a quadratic equation in terms of x. So now the x squared will be combined together. I mean the terms with x squared combined together. Then the term with x will be grouped together, and the rest will be treated as constant. So I will just write x squared plus m squared x squared, and then plus minus 6x minus 18mx, and plus the rest of the constants. So 9 plus 81 minus 18 equals to 0. So for the first bracket, I can factorize the x squared. So then you will be getting 1 plus m squared x squared. For the second term, I can factorize the x. I can take out the x. So once I take out the x, I get minus 6 minus 18m. Then the last bracket, just calculate. At last, you are getting plus 72. Okay, so when you are able to find the x, that will be the intersection point between the straight line and the curve. But then the question does not mention that, because we don't need to find the x, we need to find the m. Two possible values of m. And now, when it is tangent, straight line is a tangent to the curve, that means there's only one root. Okay, so straight line is a tangent to the curve, to the circle, right? I would say to the circle. That means only one root, one real root. Right, so when one real root, I will just refer to the discriminant. That means now my a, the coefficient for x squared, is 1 plus m squared. Then my b is minus 6 minus 18m. And then my c is going to be 72. So now b squared minus 4ac equals to 0 because of one root. Only one real root. Therefore, b squared minus 4ac equals to 0. And now this is how we find the m. So replace accordingly. You will get minus 6 minus 18m. You squared it. Then minus 4. The a is 1 plus m squared. Then the c is 72 equals to 0. And now here, right, you need to do expansion. So you square the minus 6. So again, use quadratic expansion. A minus b squared equals to a squared minus 2ab plus b squared. So I square the minus 6, that is 36. Okay, so minus 6 times minus 18m times 2. Then you will be getting 216m minus 18m squared. You square minus 18m. So that is 324m squared. Okay, now this minus 4 times with 72, that is 288, negative 288. So negative 288 is you multiply to 1 plus m squared. Then you will be getting minus 288 minus 288 m squared equals to 0. Then now again, you are getting the equation in terms of m squared now, in terms of m. It is a quadratic equation. So I simplify the terms. Now, positive 324 m squared minus 288 m squared. Then you will be getting 36 m squared. Okay, left plus 216 m. And then the two constants, 36 minus 288, that is minus 252 equals to 0. Now, this quadratic equation can be divided by 36. So I divide first to make it to a simpler form. Then it will be m squared plus 6m minus 7 equals to 0. Okay, then this quadratic equation can be factorized. So if you use the factorization method, or you can just get the factors from calculator, m squared is basically m times m. 7 is basically 7 times 1. Okay, then here, plus times minus, it will be minus. That means I should have these two signs in my 7 and 1. But then in order to get plus 6m over here, it should be plus 7 and minus 1. So that when I multiply plus 7 with the m, plus 7m, and the other one is minus m. So I will be getting m squared, and the last column when you multiply, minus 7. Then the middle term when you plus, right, that will be plus 6m. So exactly the same quadratic equation. Therefore now, my factors will be just cross multiplication. So this is my factorization. So that will be m minus 1 times m plus 7. Therefore, m minus 1 equals to 0, or m plus 7 equals to 0. So either m equals to 1 or m equals to minus 7. That's why when you read the question, it's mentioned two possible values of m. So found the m values now. Now, next part, for each m, find the coordinates of the point at which the tangent touches the circle. Tangent touches the circle, basically we are solving here. Okay, you substitute second into first. That means in this step, okay, this is to find the intersection point. Alright, so I will let this be third equation then. This is my third equation. This is the equation that will gives you the intersection point. So now I will just write from third equation. Okay, let me check. Okay, from third equation, where the m equals to 1. Right, so now replace the m by 1 first. So I get 1 plus 1 squared, which is 2x squared. So 2x squared. Then the middle term, this is m is 1. So minus 16 minus 18 minus 24. So it will be minus 24x plus 72. And we are expected to get 1 point here, 1x here, because it's mentioned only one real root. Okay, so then obviously this quadratic can be divided by 2 first. You will get x squared minus 12x plus 36 equals to 0. And this quadratic can be factorized into x minus 6 squared, which means your x equals to 6. Okay, you can write x minus 6 equals to 0. Therefore, your x equals to 6. So now the question asking for coordinates of the point. Point means x is not enough. We need to find the y. So now the y can be used, can just refer to the equation number 2. Y equals to mx minus 9. So after you found the x, I will refer to second equation. Y equals to mx minus 9. And again, now my m is 1. So m is 1. And then my x is 6. Therefore, my y equals to mx, means 1 times 6 minus 9. This is minus 3. So I get the first point. First point, 6 minus 3. Okay, repeat all these steps for m equals to minus 7. So now, again, from third equation, m equals to minus 7. So go back to the third equation. When your m equals to minus 7, 1 plus minus 7 squared. So I will write 1 plus minus 7 squared x squared. And then x times minus 6 minus 18m. So x times minus 6 minus 18, my m is minus 7. Then plus 72 equals to 0. Then from here, you will be getting this is 50 x squared. The middle term is 120x. Then plus 72 equals to 0. And this whole equation can be divided by 2 because it's a factor of 2. Then I will get 25x squared plus 60x plus 36 equals to 0. Okay, and this quadratic again can be factorized into 5x plus 6 squared equals to 0. And then here, 5x plus 6 equals to 0. That means my x will be minus 6 over 5. So found the x value, and again refer to second equation, which is y equals to mx minus 9. So from second equation, y equals to mx minus 9. Remember, your m equals to minus 7. Okay, and then the x equals to minus 6 over 5. Therefore, my y is minus 7 times minus 6 over 5, then minus another 9. Then here, when you calculate, this is going to be negative 3 over 5. Okay, so I get another point with coordinates minus 6 over 5 and minus 3 over 5. So lastly, okay, the question says, for each m, find the coordinates of the points. So here, I will just write final answer, points, just rewrite the coordinates that we have found just now. So 6 minus 3. And another one is minus 6 over 5, then minus 3 over 5. So that's all for this solution. Okay, question 11. A function is defined by fx equals to 4 over x cubed minus 3 over x plus 2. For x is not 0. The graph y equals to fx is shown in the diagram. A. Find the sets of x values for which fx is decreasing. So when the function is decreasing, that means f prime x is less than 0. Okay, but then here, since it is not continuous graph, right? Here, there is a gap. Right, they are not continuing. They are not continuous. So they are not joining. I would say they are not joining. Therefore, I just find out what when f prime x equals to 0. That will be the maximum and minimum point. Then from there, I will read the answer from the graph. So now my fx is 4 over x cubed. So 4 over x cubed minus 3 over x plus 2. Then now the x cubed can be moved up. So when you move up, it will be 4x power negative 3. Then for the second term, that is 3x power negative 1, then plus 2. And now, differentiate. So when you differentiate, use this formula. Bring down the n, rewrite the x, degree always minus 1. Okay, that means now here, the minus 3 is the power of x. So the minus 3 bring down with 4. Right, bring down and combine with 4, that is minus 12. X, the power you minus 1. So minus 3 minus 1 becomes minus 4. And then this minus 1 you bring down, combine with minus 3, that is positive 3. X, the power minus 1 minus another 1 becomes minus 2. Then now I rewrite. This is going to be negative 12 over x degree 4 plus 3 over x squared. Okay, so instead of solving this f prime x less than 0, I will just read the answer later on, okay, from the graph. what I need to do is I need to find out any intersection, any maximum points and minimum point. So now I will let f prime x be 0. That means minus 12 over x degree 4 plus 3 over x squared equals to 0. To solve this, you times the whole equation by x degree 4. Okay, so I will get minus 12 plus 3x squared equals to 0. Then now, to get the x, so 3x squared equals to 12. That means my x squared is 4. 12 over 3 is 4. So my x will be plus minus square root 4. That will be plus minus 2. So now means that I know that, okay, here is 2. This is minus 2. So now, when the fx is decreasing, that means the y value drops. So obviously, here increase, right? And then right after this point, it drops. Means that for x between 0 and minus 2, it drops. And also, from 0 to 2, it drops. Right? From here, drop. So now I will just write when fx is decreasing function, when fx is decreasing, the x is between minus 2 and 0 and between 0 and 2. Okay, or probably you can just write this. You can combine both together, or it will be from minus 2 to 2, but cannot be 0 because it is not continuous, not connected. So this is another way to write down the answer. Alright, so done for this question. Now B, a triangle is bounded by the y-axis, the normal to the curve at the point where x equals to 1, and the tangent to the curve at the point where x equals to minus 1. Find the area of the triangle. Give your answer equal to equal to 3 significant figures. Okay, so now when we see tangent, okay, or normal. So normal is a straight line. We need to find gradient of tangent. Gradient of tangent is basically dy dx. So after you have found this, then you write m normal equals to negative 1 over m tangents because they are perpendicular to each other. So now I need to find the dy dx, which is the gradient of tangent. So now my f prime x already found just now. So I will just rewrite my f prime x equals to, from the previous part, minus 12 over x degree 4 plus 3 over x squared. So I will calculate this first. Equation of the normal. So at x equals to 1. So when x equals to 1, my f prime 1, that is negative 12 over 1 degree 4 plus 3 over 1 degree 2, 1 squared. This is going to be negative 12 plus 3, that is minus 9. So this is gradient of tangent, m tangent, that is minus 9. Therefore, m normal, gradient of normal, that is negative 1 over gradient of tangent, because tangent and normal line actually perpendicular to each other. That means now here you get negative 1 over negative 9. I will get 1 over 9. Okay, and it's mentioned that the normal curve, right, normal to the curve. So I need to find out what is the normal equation. So when x equals to 1, I need to find out what is my y coordinate. So my f1, refer back to this, replace the x by 1, so denominator will be always 1. I will write 4 minus 3 plus 2. So here, I will write 4 over 1 minus 3 over 1 plus 2. That is going to be 3. That means here I'm getting a point. When x is 1, my y is 3. Okay, so now I find the equation of the normal at x equals to 1, which means use the formula y minus y1 is m bracket x minus x1. So I will get y minus 3 equals to m is basically 1 over 9 x minus 1. Then you will be getting y equals to 1 over 9 times into the bracket. 1 over 9 minus 1 is basically minus 1 over 9. Then the minus 3 you move to the right side. That is plus 3. Then you will be getting 1 over 9x plus 26 over 9. That is my first equation. Okay, equation of normal. Then now, at the same time, when x equals to minus 1, it is a tangent line. So when x equals to minus 1, I need to find out what is my f prime minus 1. So just refer back to this f prime x, replace the x by minus 1. So it will not affect the calculation because it is still positive in the denominator. Then you are getting minus 12 plus 9 in plus 3, sorry. Minus 12 plus 3, that is minus 9. That means the gradients of tangent is minus 9. Okay, so this gradient of tangent minus 9 is same as the previous gradient of tangent, which means when x equals to 1 and minus 1, the gradients of tangent will be the same. So now I need to calculate what is my f1 when x equals to minus 1. So my f is this 4 over x cubed minus 3 over x. So 4 over, this is minus x cubed minus 3 over x, then plus 2, which means here I will get minus 4, this is plus 3 plus 2, that is 1. Okay, I get a point. So which means point with coordinates minus 1, 1. And then now, equation of the tangent line. Again, y minus y1 is m bracket x minus x1. So I find these two lines first. So now y minus 1, m is negative 9, x minus minus 1. That means now here basically this minus 9 times into the x, it will be minus ix. This minus minus 1 is plus 1. Okay, here is plus 1 times minus 9, minus 9. The minus 1 here move to right side becomes plus 1. So basically I'm getting the tangent line equation as y equals to minus 9x minus 8. Okay, this is my second equation. Now you go back to the question. Triangle bounded by y-axis, the normal line and the tangent line. Find the area of triangle. So now go back to the diagram. Okay, let's say, look at the calculation. When x equals to 1, your y is 3. So which means when x equals to 1, let's say here 1, the y is 3. Okay, let's say here is the point. Just an example. Okay, now from 1 and 3, okay, from 1 and 3, we are forming normal line. And this is the y-intercept, 26 over 9. So, for your information, tangent line means it just touches at one point, right? Probably my diagram, my tangent graph is not very, this is 1, let's say. This is my tangent line, just touches. Normal line is perpendicular to the tangent line. That means here is my normal line. Okay, just an example. right? This is my normal line. Here is 90 degrees. Right? Then this is 3. Because the point is with coordinates 1, 3. And then here is 26 over 9. So I get 26 over 9 here. This is 26 over 9. So 26 over 9 is actually 2.89. Okay. And then the other tangent line, the coordinates minus 1, 1. And it is minus 8. The y-intercept. So minus 1, 1. The here. Let's say here minus 1, 1. That means somewhere here. This is minus 1. Okay. Or probably my minus 2 is not here. A bit further. Maybe minus 2 is here. So then minus 1, 1. Let's say here is 1. And then it has a tangent line. Tangent line. Okay, this tangent line, look at the gradient. Okay, at first, the first gradient is minus 9, the gradient of the tangent at x equals to 1. Then, when x equals to minus 1, the gradient of tangent is also minus 9. That means these two lines are basically parallel to each other. Okay, parallel. Okay, so that means if here is 90 degrees, here is also 90 degrees. Because the green line and the blue line are actually perpendicular to each other. Okay, perpendicular. Now, what we need to do is we need to decide where is the triangle. So it's mentioned that the triangle is bounded by y-axis, the normal line, and the tangent line. So which means now my triangle, I have to extend my blue line. Okay, my triangle is over here. So now if you need to find out the area, but before that, for the tangent line at x equals to minus 1, I know that the y-intercept is minus 8. So which means now I will label my graph. Here is minus 8. Okay, so from here, first of all, I need to find out what is the intersection here. Because to find this area of triangle, I know that here is basically 26 over 9 plus 8. Okay, because 0 to 26 over 9 is 26 over 9. 0 to minus 8 is 8 units. So I know that this is the value. So as long as I know what is this height, right, then I will just refer this value as the base of the triangle. And then this horizontal line will be my height of the triangle. Okay, so that means I need to find out what is my intersection between the normal line. This is our normal line. And the tangent line. This is the tangent line. So the intersection will be just the solving the simultaneous equations. So what I need to do now here is I will have to solve the equations that we have just formed, first and second. So now I will just write first equation equals to second equation. So 1 over 9x plus 26 over 9 equals to minus 9x minus 8. Then now solve for the x because we need to know the x value. So this minus 9x move to the left hand side and 26 over 9 move to the right side. So it means that I will be getting 1 over 9x plus 9x equals to minus 8 minus 26 over 9. So left side you will be getting 82 over 9x. Right hand side is minus 98 over 9. Then now, to get the x, the 9 will be cancelled off from both denominators. Then the 82 will be moved down. So that means you will be getting x equals to minus 98 over 82. That is going to be minus 49 over 41. And this value is basically negative 1.195. Okay, so I will just label negative 49 over 41 on my diagram. So I know that this point here, it is negative 49 over 41. Okay, which means, right, which means this distance is 49 over 41. So now I can easily find the area of the triangle, which is the shaded region, this part, whereby this value will be my base. Okay, so now I will draw the triangle on my working. So that means here, this is question 11, part B. So I will draw the triangle. So this is going to be 49 over 41, and here is 26 over 9 plus 8. Therefore, my area of the triangle is half. This becomes my base. Here is my height. Okay, so it's like this. Here is my base, and this is my height. So it becomes half times base, 26 over 9 plus 8 times the height, 49 over 41. Ignore the minus, right? Because we are counting the magnitude. Then when you calculate this, this is going to be 6.5068. And now we always round up to 3 significant figures. Let's see any constraint. Give your answer to 3 significant figures. So therefore, here is going to be 6.51. Okay, so this is the explanation to get the area. So you have to find out the line, the two lines, okay, normal and tangent lines. And you should know that both tangent lines at x equals to minus 1 and 1 are having the same gradients because they are parallel to each other. Okay, so with this, I have completed this paper and also comes to the end of the video. Thanks for watching. Please subscribe to the channel and share this channel with everyone, right? If you enjoy watching the videos. Okay, thank you everyone. Bye.